Working at the University of Kentucky for the past 11 years as a professional research engineer, Brad Rister will be describing one of his many projects, the LiDAR.
LiDAR is essentially a spinning laser. It works in the infrared spectrum, and basically everything that light touches, you will get an X and Y, Z coordinate on that particular point. The point cloud that the LiDAR equipment creates is 400,000 points per second, and as long as the equipment that you're using is geospatially connected, that's to GPS coordinates, then therefore all your LiDAR data will then be geospatially corrected, or have true X, Y, and Z coordinates, or lat, long, and altitude positions. Probably the single most important thing about LiDAR and its opportunities in the future is it revolves around safety. The equipment is able to be mounted to a truck, and you're able to drive a roadway and collect all of your surveying data at about 50 miles an hour. So that means you're able to collect your survey files for your design drawings while you're mixed in with traffic. That keeps people from having to work on the roadway to take elevation shots, things like that. It also has the ability to collect upwards of about 60 to 70 miles of precise survey grade quality in a day's time.
Okay, so what you're looking at here, this is actual collected LiDAR data, and we're looking at, this is downtown Lexington, this is Vine Street, this is Main Street, and this is where we've gone through downtown Lexington at about 20 miles an hour, and we've done just one pass with our mobile LiDAR truck. You can see that we're able to flip the model upside down where you can see underneath the roadway, and then obviously you can see where the different buildings are, where the crosswalks are, where the lane lines are. A nice feature of this is that we have about 2,500 points every inch. So each one of those points has its own X, Y, and Z coordinate. It has a lat long and a elevation. So we can take this data and we can measure between any 2 points. And since LiDAR is highly accurate, our point measurement will be off about plus or minus about 2 millimeters. So we could easily see how tall the bridge was above the roadway, how wide the road is, how far back that truck is. So this could be our platform for all of our survey data that we've collected, and we were able to do that in about 10 minutes of just driving downtown Lexington and then collecting it out with collecting the data during normal hours of the day along with other cars and trucks.
Mostly LiDAR in a generic sense, consulting companies will go out and they will scan a roadway to identify where they want to make the improvements, whether they want to make the road wider or put in new signals, things like that. That's kind of their traditional sense. What we throw in the research component is we are also coupling LiDAR, which is a 3D model above ground, with ground penetrating radar, which is a way to look beneath the surface and to identify pipes, pavement layer thicknesses, and things like that. So we're trying to create a 3D model both above ground and below ground. I think LiDAR will become a part of both pre-construction and the design. You will use it to design your roadway facilities or building facilities from. You'll use it during construction to monitor your progress and as things need to be changed on the fly. And then it's a great way to come in and do your as-built information. So once the project's built, you can then check to make sure that the project was built correctly. It's also being looked at to be put into different types of machinery that can be used for machine control, so that you can basically upload your 3D model that has your geodetic control, and then you can just use the GPS guidance on machines to cut, roadways to grades and build the infrastructure that way.